Hello everyone, my name is Yasin Rahim and the topic of my presentation is Geochemistry of Sedimentary Rocks from North China Craton, Implications for Provenance, Environmental Deposition and Tectonic Settings. My advisor is Professor Dr. Chugan Lee. This is my personal information. I am from Pakistan. I am a PhD candidate in Institute of Geochemistry, School of Earth and Space Sciences, Peking University, Beijing, China. I have done my master's in applied geology from Pakistan. I have served in three different organizations. My initial work was as a trainee geologist in a hydropower project in Pakistan. It was basically construction of tunnels for a hydropower project. Then I served for hydrocarbon exploration and oil and gas company based in Pakistan as an intern geologist. My most recent work was as exploration geologist in Northwest Minerals, Pakistan. It was basically a joint venture of Pakistan and France, and they were looking for industrial minerals. After that, in 2019, I came to China to pursue my PhD. And these are my research publications so far, which I have managed to publish. You can see the DOI numbers if you are interested to see and read the research papers. Now, coming towards my research project, the topic, as it is mentioned above, geochemistry of sedimentary rocks from North China Craton as NCC. So this is the area basically North China Craton where I am working on sedimentary and meta-sedimentary rocks. The implications. The implications of this research is basically to identify provenance, environmental deposition, tectonic settings, and sedimentary processes. And how we are going to do that is I will discuss in the next slides. For provenance identification, there are various ways to identify provenance, but the most important and widely used are the three factors like quartz, feldspar, and rock fragments. By quartz, we can identify the provenance easily, and these are the diagrams which are used, and we can plot our data in these diagrams to find the provenance through quartz. Then through feldspar, this is a pressure temperature diagram, and through this diagram, we can also identify the provenance with the help of feldspar. Then we have rock fragments. They are also of great importance because it gives us the information about the extraterrestrial and intra basinal information. And this diagram is used to plot our data and we can get the information. So all these diagrams have their own importance to identify provenance, and all together combining them we can easily and precisely find the provenance. Then environment of deposition. Environment of deposition mostly people used to find through pathological studies by studying thin sections of rocks and finding the grain size, the matrix, and the cementing material, the genetic changes. But recently they have been using geochemical analysis also to identify the environment of deposition. So I have selected three main diagrams. The first is trace element diagrams. With the help of trace element analysis, we can identify environment of deposition. We have the strontium rubidium average diagram through which we can find environment of deposition, and also this manganese and iron diagram. Through this we can also identify the environment of deposition. Environment of deposition is basically the conditions and the place, how the rock was formed, how the sediments came, how the lithification occurred, how the consolidation occurred. Basically how a rock formed, in what condition it was formed, is basically known as the environment of deposition. It is mostly marine for sedimentary rocks. Then we have tectonic settings. Tectonic setting is also of great importance because it gives us the aside to a history that what were the plate movements at those times when these rocks were in under formation. So what influences these tectonic settings were happening when the rock was under construction. So it can also give us a lot of information. These are two different diagrams which can help to identify the tectonic settings. I cannot go to detail because the shortage of time, but I will shortly describe them as this area. If we ore data comes in this area, which means that OIA means oceanic island arc, so it will be from setting of oceanic island arc. As for this other CIA as continental island arc, active continental margin and passive margin. So by these diagrams, you can identify the tectonic settings. Then we have implications as sedimentary processes. Sedimentary processes include sorting and recycling, diagenesis, weathering. Sorting and recycling, because these are sedimentary rocks, so these sediments may have been arrived from one rock or multiple rocks, and maybe these sediments are recycled. Like when the rock was formed, it was weathered again and it formed again. So maybe these sediments are multi-cycled. So in this diagram, it is shown that with time, these sediments has been uh, recycled again and again, and finally they form in the rock. So it is difficult to identify that from where actually these sediments have been arrived. This is the diagenetic diagram. Diagenesis is basically the chemical and physical change in a rock with low pressure and temperature changes. So we can see these minerals, especially feldspar, it converts into clay minerals like smectite, kyanite, illite. So when we have these clay minerals, it can trace back to the original mineral that it was feldspar. Then we have weathering. Weathering is also a very important factor to find, because when a mineral is weathered, as I give the example of feldspar, it converts into clay mineral. So when we have these minerals as a product, it can help us to trace back the weathering, that how this mineral was converted from feldspar. So it can give us a lot of information about that. Now, what of methodology we are going to use? Whole rock geochemistry is the main theme, that we identify the rock by doing its whole rock geochemistry, and these are the analyses which have been used: major element analysis, trace element analysis, rare earth element analysis, heavy minerals analysis, and geochronology analysis. All these analyses have their own importance and which cannot be discussed in detail because shortage of time, but I will give you a small and brief information as I can. Major elements analysis, they are mostly done by XRF, and these are the Cordero diagrams in which we can plot our data, and these are the different areas which can help us to identify provenance. So previously, as I told you, the provenance can be identified by quartz, feldspar, and rock fragments, but also from major elements we can also identify quartz. Same as this is another diagram which can also help us to identify provenance by major element analysis. Then we have trace element analysis. Trace element analysis also help us to identify provenance, and we use them. These are the values which we obtain from our samples, and this is the standard sample of upper continental crust. So by trace element analysis, we can also identify deposition environment and provenance both. Then we have rare earth elements. For rare earth elements, we use LAICP-MS analysis, and we identify the abundance of rare earth elements in our sedimentary rocks to identify the provenance and environment of deposition. The process is a very hectic and a very lengthy process, so I cannot go in details, but this is an overview that through rare earth elements, we can also identify uh, environment of deposition and provenance. Then we have heavy minerals analysis. For heavy mineral analysis, we do simple pathological analysis or cathodoluminance SCL analysis. This is a diagram, and these are different binary plots of heavy minerals stability indexes like zircon tourmaline rutile, apatite tourmaline. This one is garnet zircon index, and this is rutile to zircon. So all these indices, when we plot our data, it gives us the information which can be get the information about the heavy minerals to identify provenance and also the origin, that from where it has been arrived. Then we have geochronology. Geochronology is basically to find the age, and it is done through radiogenic age dating. For that, we have ICP-MS analysis and cathodoluminance CL analysis. This is a zircon data, and these are the grains. These grains, these images are taken in cathodoluminance as CL images, and these are the target areas which has been analyzed by ICP-MS to identify the age of that rock. So it can help us to identify the age of the rock to find the tectonic settings and also the provenance. Now, the results are too much lengthy and incomplete because I'm still in my process of experimental phase, so I don't have the exact information. So I will share that what type of results I'm going to get. So I will get provenance source, like source of provenance will be identified by my research, sedimentary processes such as sorting, recycling, diagenesis, and weathering, deposition environment, that if it was shallow marine, deep marine, or what type of environment was. Paleo environment, that ancient environment, that what were the conditions, what were the climate, what were the ocean situation, its composition when this rock was deposited. Then tectonic environment, if it was active continental craton or passive margin uh, tectonic setting. Then the age dating, it can also be done to by identifying the fossils, but through chemical analysis we cannot use fossils as analysis. So we use isotopic age dating. By some heavy minerals we identify age dating to identify the provenance. Now, my future plans after completion of my PhD, I am planning to go back to my country and help my academic institutions and apply this information which I have learned. Because when I was coming to China, the reason was that in Pakistan we don't have institutions which can give us geochemical or geochemistry education in higher education. So because of lack of that education, I had to come to China and learn this information. So I'm willing to go back and share this information and help back my country and these organizations like the hydrocarbon and mineral exploration sector or academic sector to do better research in the field of geosciences. So this is all what I have to share. I'm sorry if I couldn't explain it properly because there is a lot of information and the time is limited. So explaining each and everything in the possible way that you can understand and you can get all the information is very difficult. So I tried my best. I hope you have at least got some of the information I tried to share with you. So if you have any questions, uh, I have my contact in my CV, my email, so you can contact me. So that's all. Thank you for watching and listening to me, and wish you all the best.